Students, let us today discuss about the nature of the covalent bond. In the early session, we have studied about the ionic bond. Then when I told about the covalent bond, I told let us go and discuss about quantum numbers, Haber principle, Pauli exclusion principle, and Hund's rule. So now to continue with that, now we are got enough knowledge with those concepts. So we are today moving to covalent bond. What is the atomic number of carbon? 6. Very good. The atomic number of carbon is 6. So in the first shell, how many electrons will be there? So how many protons will be there? 6. How many neutrons will be there? 6. Okay. In the first orbit, how many electrons will be there? In the first shell, 2. K will be 2. What is the L shell? L major energy level. What is the number of electrons? Total 6. So 2. Remaining is so what is the valency of carbon now? Valency of carbon is 4. This is a crude method. This is not the right method. This is not the right method of finding valency. It is actually wrong. We should not go like this. But as a fairly, if I'm going to see from outside view, then the valency of carbon is 4 because there are 4 electrons in the outermost shell. But to be more precise, we have to write the electronic configuration. What is the electronic configuration? 1s2, 2s2, then 2p2. Now 1s2 will be there, 2s2 will be there, 2p2. As I told you, it will have px, py, pz. So it is 1. It is also what? 1. Now what is valency based on this one? Like this only we have to find the valency. Valency is nothing but number of unpaired electrons in the outermost orbital. Okay. So here valency is not like this. Just you used to tell the valency of carbon is 4 because it has 4 number of electrons in the outer shell, but it's not the proper definition. When I'm coming to proper definition, I had to go with the electronic configuration. So it's 1s2, 2s2, 2p2. So now, not only the number of electrons in the outermost orbital, but also unpaired. Here, how many is unpaired? 2 is unpaired. So what is the valency? So the valency of carbon is 2. Here the valency of carbon is what? 4. The right method gives a wrong answer. The wrong method gives the right answer. Actually, the valency of carbon is what? 4 only. We know that. Everybody knows the valency of carbon is what? 4. So the right method gives a wrong answer. The almost generic method gives a more accurate answer. Then how? Means before this carbon is going to get reacted, what will happen means this is called as ground state. This is called as what? Ground state electronic configuration. Ground state means normally. But whenever this carbon is going to react with other elements, it will go to the excited state. If the kids are at the home, they'll feel bored, they'll simply do some work, or simply they'll tell we are getting bored, they simply sleep. But if you are going to tell that we are going for excursion, they'll get more energetic and they'll be going here and there, they'll be joyful. That is called as excited. That is called as what? Excited. So similarly, when this carbon is going to undergo reaction, it will be transformed from the ground state to the excited state. How it will go from the ground state to the excited state? By absorbing energy. Without energy, it can't be pushed away. So by absorbing this energy, the ground state electronic configuration will be going to the excited state. So now I will draw this 1s2. Here one of the electrons in the 2s orbital will be promoted to 2py orbital. This is what? 2s orbital. This is what? 2p. So here it will become what? This electron which is in this direction has been pushed over here and it will be like this. So one of the electrons from 2s orbital is pushed to 2p orbital. So whether 2p orbital has more energy or less energy compared to s? 2p orbital will have more energy or less energy? It will surely have more energy. So it's either it's possible to transfer one electron from 2s to 2p. No, it's not possible without extra energy. When it's going to gain some energy, then it can be pushed. If it's not gaining any energy, it can't be pushed. It can't be pushed. But whenever this carbon is going to undergo some chemical reaction, just like the kids got enthusiasm by going outside for a excursion, for a play, something like that, this 2s electron also got energy from the other elements. And one of the electrons from the 2s orbital will be promoted to what? 2p orbital. Now, how many electrons are there? Unpaired electrons are there? 4. So, what are the values of carbon? 4. So, this state is called as excited state. This state is ground state. When it's not reacting, it will be in ground state. Whenever it's going to react with other elements, it will become excited state. It will become what? Excited state. So, what is the valency now? 4. So, the valency of carbon is 4. Here also the valency of carbon is what? 4. Let us not go deeper still further. Let us stop here. Actually, we want to take still further, but I will cover those in the next session. Otherwise, we can't cover this covalent bond. Okay. Okay, let it be. I will try to cover that also if possible. Now, carbon is there. Is having 6. His valence is what? 4. By any method, his valence is what? No. 4 only. What happens to sodium? Sodium, his atomic number is 11. His atomic number is what? 11. So, what are the electrons? 2 and 8 and 1. If it's going to give away this one electron, it will become stable like neon. It will become stable like what? Neon. So, Na will become what? Na plus 1 electron. This I already told in ionic bond. This already we have discussed in ionic bond. Here the number of protons is 11. Number of electrons is 11. So, the charge is 0. Whereas here, one electron is moved away. So, the number of protons is 11. Whereas the number of electrons is only 10. So, what is the total charge? It will be 1 positive. That positive only we have written like this. So, this reaction is called as oxidation. This topic also we have covered in this balancing of ionic equations. So, this reaction is called as oxidation. What is oxidation? Removal of electrons. So, when one electron is removed, it becomes oxidized. So, Na becomes Na plus. It becomes sodium ion. It becomes what? Sodium ion. Now, let us come to the case of carbon. So, first orbit is 2. Second orbit is what? 4 now. Let us take now carbon. So, it is neutron is 4. Neutron is 6. Proton is 6. Okay, so 2, 4. Now, if it has to attain octet, it has to gain 4 electrons. It has to gain what? 4 electrons. So, absorption of electrons is called reduction. Absorption of electrons is called what? Reduction. So, this carbon is going to absorb 4 electrons. It will become C4 minus. You may also tell, sir, why it has to absorb 4 electrons? Why can't we give this 4 electrons? It will become like helium. It will become like helium. It will also become stable. So, let us tell this carbon can also give 4 electrons. So, carbon becomes C4 plus 4 electrons. Isn't it? Either carbon, by giving away 4 electrons, will become like helium. C4 plus will become like what? Helium. On the other hand, carbon by absorbing 4 electrons will attain octet statement. C4 minus will attain octet statement like what? Neon. But these both things are not possible. Why this is not possible? Why this is not possible means because let us say I am going to remove an electron. When I am going to remove an electron, it becomes instead of 4, it will become what? 3. So now the number of protons is what? 6. The number of electrons is what? Only 5. So positive charge is 6, negative charge is only 5. Now I have to give some other energy to remove this electron. Now the bondage will be more or less? It will be still more because here there are 6 protons, 6 electrons. So it's possible to remove easily. But now the positive charge is more, negative charge is less. So the nucleus will try to pull these 5 electrons more closely. So if you want to remove one more electron, I have to give more energy compared to the earlier one. So the second ionization energy will be more than the first ionization energy. Then let us say I am trying to give more energy and I remove one more electron. So it becomes plus 6 and only 4 electrons. So it's minus 4. Now whether I have to supply energy, whether it will be more or less, still it will be more. So this is not possible. Similarly, gaining of electrons is also not possible. How it is not possible to remove the electron from the carbon atom? On the other hand, it is also not possible to gain the electrons, to absorb the electrons. So these two things are not possible. So there is no possibility of forming either C4 plus ion or C4 minus ion. So there is no cation or anion will be formed by carbon. Whereas sodium will easily form sodium plus ion. Chlorine will easily form chlorine minus ion. But carbon cannot form C4 plus ion or C4 minus ion. But anyhow, it has to be stable. Anyhow, it has to be stable. It has to arrange a octet arrangement. For that, then what is the concept? Now let us take what is the outermost number of what is the number of unpaired electrons in the outermost orbital? 4. So I am going to indicate that 4 electrons as 4 X symbols. 4 X symbols. Now hydrogen, what's atomic number? 1, which means it has 1 electron in the outer orbital. So 1 unpaired electron. So this is 1. This hydrogen, I am taking a second hydrogen. That hydrogen also will have 1 electron. Third hydrogen, that will also give 1 electron. The fourth hydrogen, that will also give 1 electron. Now what is bond? The bond, ionic bond is nothing but the bond between the ions. Ionic bond is nothing but the bond between the ions. Covalent bond is formed by mutual sharing of electrons. So I will define now only what is covalent bond. It is nothing but mutual sharing. The word is very, very important. Mutual sharing of electrons. What is maybe mutual sharing? If you are giving 1 electron, I will also give only 1 electron. If you give 2 electrons, I will also give 2 electrons. That is mutual. It is called what? Mutual sharing of electrons. So mutual sharing of electrons result in the formation of a covalent bond. So what is a bond? Bond is nothing but a line. Line is formed between 2 points. Here the points are nothing but the electrons. So instead of these 2 electrons, I can draw a line between them. It's nothing but the covalent bond. Here also become what? Covalent bond. This also become what? Covalent bond. This also become what? Covalent bond. Now the molecule is called as what? Methane. CH4 is nothing but what? Methane. I used to write like this earlier. C has a valency of 4. Hydrogen is having a valency of 1. So cross multiply them. Then I'll write C1H4. This one also we discussed earlier in the system of valency. So it will become, instead of writing 1, it's enough to write CH4. So this is CH4. So what is the bond in methane now? It's not ionic. It is covalent bond. It is nothing but what? Covalent bond. So now it becomes what? Instead of writing this dotted line, it's not required. H. C. Got it? So whenever you are seeing a bond, covalent bond, what does it indicate? There are 2 electrons. There are 2 electrons which have been shared equally. You are very good. So whenever you are seeing a line, line will start with 1 point and end with another point. One other point is electron, another point is also electron. So a bond is formed between 2 electrons or mutual sharing of electrons. Now, if you are going to ask this carbon, if somebody is going and ask whether you are stable or not, this carbon will tell, I am stable. How? You see, around me there are 8 electrons. 2, 4, 6, 8 electrons are there with me. So I am stable as that of neon. I am stable as that of neon. If I am going to ask the hydrogen whether you are stable, yes, this hydrogen will tell, I am quite stable. I am having 2 electrons. I am like helium. This hydrogen also will tell, I am just like what? Helium. This hydrogen also will tell, I am stable like what? Helium. This hydrogen also will tell what? Helium. That is, they got benefited mutually. They got benefited what? Mutually. Carbon attains the octet arrangement of neon. Hydrogen attains the stable configuration similar to what? Helium. So both attain stable things. So this type of bond is called as covalent bond. This bond is also stronger, but here the melting point and boiling point of this covalent bond is relatively lesser compared to the ionic bond. There we want to supply more energy. So the melting point and boiling point will be more. Whereas here the melting point and boiling point will be lesser. Any doubt here? How the covalent bond is formed? Why the CH4, etc. Now can I ask a doubt? Okay. Here, one of the electron is from 2s orbital. One of the electrons is from what? 2s orbital. The other 3 electrons are from what? 2p orbital. So out of this carbon, one is S. Other 3 are what? P. So whether the bond will be having equal strength or different strength? Equal strength. How? No. What you told is right. The answer is right. But we know that S has lower energy. So this electron will have lower energy. This P electrons will have more energy. So I generally prefer that this bond formed by P electrons will have more strength compared to what? The bond formed by S electrons. But what you told is right. All the bond will have equal strength. But how? Now only the concept of hybridization come into picture. You put this one electron, 2s electron into a box. This is what? 1, 2s. You put 3 electrons from 2p level, 2px, 2py, 2pz. Got it? Don't worry about 2. 2 is nothing but your principal quantum number. So 1 s electron and 3p electrons, I am going to shake well. I am going to make what? Shake well. And I am going to make, how many electrons are totally there? 4. Now I am going to make 4 sp3 electrons, hybridized electrons. So there is no s electron, there is no p electrons. Now the electrons are called as 4 sp3 hybridized electrons. So all the electrons are not, it is not like 1 s and 3p. All are sp3 only. All are what? sp3. But all are of equal strength. All are what? Equal strength. So the bond between all the carbon compounds are similar. So here we explained about the concept of what? Hybridization. So if I have not explained the principle of hybridization, then you may feel the S bond will have lower energy. So it's a weaker bond compared to the other 3 bonds. It's not like that. All the bonds are equal in strength, which means I am undergoing a process called hybridization. What is hybridization? You take a box. For example, I am telling. You can't, I want you to understand. So you take a box. You put this 1 electron from 2s orbital, put it. Then you pick all the three electrons from the p orbital, throw them, mix them. Then you take 4 electrons. Now all the 4 electrons will be have equal energy. That 4 electrons will react with your 4 hydrogen atom. Now it will be formed as what? Your covalent bond of equal strength. Now there's one more doubt. I will not leave you. Okay, so you can see here H, C, H, H, H. Now this is a electron from hydrogen carbon, this is an electron from hydrogen which makes a bond. Now, even though it's mutual sharing of electron, both have equal power to share this electron, but really whether it will be like that. These 2 electrons should be commonly shared. That is the meaning of covalent bond. Yeah, they shared commonly. Now the electrons are in common. So hydrogen is helium, I am like helium. Carbon is helium, I am like neon. Now my question is, even though these 2 electrons are in common, but which country, which will have more pulling power towards it? No, but the bigger fellow is carbon. The carbon is like me, a bigger fellow. Hydrogen like you, a smaller fellow. So even though we are telling mutually he'll have something, but I'll try to pull. It is not actually good. We have signed an MOU that will keep these 2 electrons common. Like that only we signed. But even then, I'm a superior person than you. I'm somewhat bulky. Then what I'll try to do means, I'll try to pull this electron towards me. That is, it will not completely come towards me. But more or less, even though we are signing an MOU, but we are not giving that much of 100% liberty to that guy of hydrogen. We are almost, it should be 50-50, but we will always try to have 53, 55. We will not go beyond. If we go beyond, hydrogen will go away. No, I will not join with you, like that it will go away. But even then, the carbon has a tendency of pulling this electron towards this one. So, even though there is a covalent bond, there is no charges, but there is a chance this hydrogen can leave away the electron to a certain extent, not fully. This carbon can also absorb this electron towards it to a certain limit. So when it's absorbing the electron, it becomes delta minus. When it's leaving this electron, it becomes what? Delta plus. But this delta plus is not like sodium and chlorine. It's very less. It's very, very less. This character is called as ionic character in covalent bond. This character is called as what? Ionic character in covalent bond, because even though there is a carbon and hydrogen, there are 2 electrons in between them. It should be mutually shared, we agree. The agreement is also there. But even then, this carbon fellow is a bulky fellow compared to hydrogen. This will be having always some superior nature. It will try to pull the electron towards it. So it becomes delta minus. Not fully. Very, very small. Delta means very small. Whereas this hydrogen will become what? Delta plus. So this character is called as what? Ionic character in covalent bond. Okay, ionic character in the covalent bond. Now let us take hydrogen and hydrogen. Let us take what? Hydrogen and hydrogen. What is the atomic number of hydrogen? 1. What is the electron? 1 electron. This hydrogen also will give what? 1 electron. What is the bond formed between them now? There is ionic or covalent bond? Covalent bond. Now you tell me, now whether there will be any ionic character here. Now there are 2 electrons. Both are hydrogen. So whether one of the hydrogen can pull it towards it? No, because both are equal power. Both are what? Equal power. So here there is no ionic hydrogen covalent bond. There is no ionic hydrogen covalent bond. Whereas in carbon hydrogen, there is ionic hydrogen covalent bond. Whereas here there is no need. So always a covalent bond need not to have ionic character. It depends upon the type of molecule. Okay. In ammonia, you tell me now. Ammonia is will be having like this. Whether ionic character will be there or not, it will be there because they are not same. I hope you might have enjoyed the lecture and I hope it will be useful. Thank you.